Okay, morning. So, as I mentioned in the first class that I should cover that how the sound wave is generated and then sound transmission. So, next few lecture will be on sound generation and sound transmission. Okay. Now, if I say what is sound? Now, I have already said the sound is generated through a mechanical vibration of a medium, maybe solid, maybe liquid or maybe air, I do not know, any medium. So, any medium, if the medium is vibrate, a sound is generated. Now, sound has two properties. You heard about that. Sound means which is I perceive, may not be. Human perception is stand for 20 hertz to 20 kilohertz. If a sound wave frequency are lie between the 20 hertz to 20 kilohertz, then I said it is a audible sound by human being. Maybe after 20 kilohertz, sound may be perceived by some other animal, I do not know that, may be perceived by some other animal, yes, it is perceived by some other element. So, that means as a human being, it is audible sound if it is 20 hertz to 20 kilohertz. Okay. So, here I know the frequency of vibration. So, that is I will come how to know the frequency of vibration. Okay. Now, below that 20 hertz sound wave, after 20 hertz, 20 kilohertz, what is that called? What is that sound wave called? Supersonic or not supersonic, sorry, ultrasonic. That means I cannot hear that sound, but sound is vibrating, mechanical body is vibrating. Okay. So, whether it is audible or not, we do not care. We said any mechanical vibration create sound. It may be audible, if it is vibration frequency 20 hertz to 20 kilohertz, it is audible. If it is above, it is not audible, it is below, it is not audible. But sound wave is there and energy is transmitted. And then we said that vibration create the movement of the particle and that particle movement transmit that energy from one point to another point. So, let us first start with that vibration. What is the vibration? We said if I strike this board, a sound is generated. How it is generated? Because of mechanical vibration. Okay. So, what do you mean by mechanical vibration? You know simple harmonic motion, everybody know the simple harmonic motion. That means, let us consider any mechanical things is nothing but a spring mass system. That means, a spring connected with a mass m s. S is the stiffness of the spring constant of the spring, m is the mass attached with the spring. So, any vibration I can say is a mechanical oscillation, and mechanical or simple mechanical oscillator is nothing but a spring connected with a mass. Now, as per the Hooke's law says that if I apply a force or if I deform the spring started oscillation. So, that force is nothing but a proportional to displacement of the mass. M is displaced, spring is squeezed. So, M is if the x is there. So, if I move that mass this side and release it, it will vibrate. So, mechanical vibration will be happen. That means, a mass will be displaced in this way, and Hooke's law said if there is no external force applied in this system, that means there is no friction, there is no damping, no friction means no damping. So, there is no external force on that system, then it is create the oscillation will be sustained. This mechanical oscillator will be oscillated with a constant amplitude. With a constant amplitude, oscillation will be not die down. Okay. So, this oscillation is called simple harmonic motion. So, this x the displacement of the mass follows a simple harmonic motion. That means, displacement of the mass should be in the form of a sinusoidal function. So, cos omega t, what is the omega? Omega is nothing but a frequency. So, that is why it is called simple harmonic motion. So, the displacement should look like a simple harmonic motion. Okay. So, it has a frequency and it has a constant amplitude. There is no external force applied to the system. As per the Hooke's law said force is proportional to displacement and it is negate opposite direction of the applied force. So, that is why it is F is proportional to minus x. So, we said F is equal to Sx. So, F plus Sx should be 0. So, what is force? As per the Newton's second law of motion, a force is nothing but a mass into acceleration. So, what is acceleration? If it is x is the displacement, so acceleration is d2x by dt square. So, this equation become m d2x by dt square plus Sx is equal to 0. Okay. So, d2x by dt square plus s by m x is equal to 0. Now, if I consider that s by m, let us omega 0 is equal to root over of s by m. Okay. Then this equation is nothing but a d2x by dt square plus omega 0 square x, omega 0 square x is equal to 0. Okay. This omega 0 is called the natural resonance frequency of that simple oscillator. That means, if I applied a force here, the oscillator will be oscillated, and if the mass is m and stiffness is s, natural resonance frequency of this mass system is root over of s by m. So, if I increase m, what is the physical significance? If I increase m, omega 0 will be decreased. If I increase s, omega 0 will be increased. So, if you see, if a tension of the spring is very hard or spring constant is very high, if you strike it, it produces a sound which is in high frequency. Okay. Now, if you increase the mass of the spring, then and there it produces the low frequency. Okay. Similarly, just think about a membrane vibration kind of things. If you see the drum, huge drum, if you strike the drum and if you see the small drum, if you strike the drum, if the tension on the both the drum is same, what will happen? Large drum will produce a low frequency, small drum produce a high frequency. If you see the digi tabla, tabla is large membrane, digi is small, digi is large membrane, tabla is small membrane. So, if you strike here, low frequency I heard, and if you strike here, high frequency will be high because its area is very small and mass is small, and here mass is high. So, low frequency will be high. So, if I increase the mass, vibration frequency will be decreases. If I increase the stiffness, frequency will be increases. You know that things. Okay. So, that means a huge microphone may not be able to produce the high frequency. So, that we will understand, that will say why it is not produced the high frequency and what are the extra arrangement we should make. So, those things will done in the microphone design. So, actually you should know physically meaning of that natural resonance frequency, increased mass, natural resonance frequency low, increased stiffness, frequency will be high. Okay. Now, forget about this part. Now, come on here. Now, this is the second order differential equation. This is nothing but a second order differential equation. So, if I want to solve this second order differential equation, so I can say there is a general solution of this differential equation for the displacement x is nothing but a1 cos omega 0 t plus a2 sin omega 0 t. This is the complete solution of the differential equation in cosine term, where a1 and a2 are the arbitrary constant. We do not know the value of a1 and a2 are the arbitrary constant. How do you get the arbitrary constant value? By putting the initial condition. What is initial condition? I said at t equal to 0, x is nothing but a x0 and u is nothing but a u0. What is u? u0 is the particle velocity. If displacement is x, dx dt is the particle velocity, motion equation or velocity. So, velocity is nothing but a dx dt. So, at t equal to 0, I said that this system has initial displacement of x0 and has initial speed is u0. Then, if I put that things in this equation, what I will get? So, at t equal to 0, x is nothing but a x0. So, I can say x0 is nothing but a a1. I put that t equal to 0, cos 0 1, sin 0 0. So, a1 is nothing but a x0. Now, if I take the first order derivative of this equation, so u is nothing but a dx by dt. So, it is nothing but a1 sin omega 0 t, and omega 0 will become here and it will be minus cos differentiation. Then a2 omega 0 cos omega 0 t. Okay. Differentiation of sin omega 0 t, omega 0 t. Okay. Now, at t equal to 0, u is nothing but a u0. So, it is, if it is u0, then I put t equal to 0. So, this term will be 0, sin omega t 0, sin 0 0, and this term will be exist. So, a2 omega 0. So, a2 is nothing but a u0 by omega 0. So, I get the value of a1 and a2. If I put that value in here, what I will get? X is nothing but a x0 cos omega 0 t plus a u0 by omega 0 sin omega 0 t. Okay. So, this is the solution of that equation. Any doubt? Okay. Now, I want to write this equation in another form, because if I write a1 and a2, we always heard about something a cos x is equal to a cos omega t something. So, I want to write that way in this equation. Let us consider a1 is nothing but a cos phi. A and phi are arbitrary constant, I can write, and a2 is nothing but a minus a sin phi. So, I have to know only the a and phi from the initial condition. Same equation I can write a cos phi cos omega 0 t plus minus a sin phi sin omega 0 t. I just put the a1 and a2 value. So, cos a cos b minus sin a sin b, cos of a plus b. So, I can write x is nothing but a cos omega t plus phi. Okay or not? Okay. Now, then from the initial condition I know the value of a1 and a2. Now, same initial condition I should get the value of a and phi. Okay. Now, if I see a1 and a2, a cos phi, a sin phi, Now, what is x 0? I can, if I take the square, so I say a1 square. So, if I want to say that, okay, I write a square cos square phi plus a square sin square phi is nothing but a1 square plus a2 square. Value of a1, a2, I take the square only. Now, if I say a is common, so a square is nothing but a1 square plus a2 square, because cos square theta plus sin square theta is equal to 1. Okay. So, a is nothing but a root over of a1 square plus a2 square. Now, what is the value of a1 and a2? a1 is nothing but a x 0. So, I can say a is nothing but a root over of x 0 square plus u 0 by omega 0 whole square. Okay. Same a. Similarly, if I say a1 is equal to a cos phi. So, if I a cos phi divided by a, or I write a minus a sin phi divided by a cos phi is nothing but a2 by a1. a1 is equal to a cos phi and a2 is equal to minus a sin phi. So, a cancel. So, minus tan phi is nothing but a2 by a1. What is a2? u0 divided by omega 0. What is a1? x0. Okay. So, if it is x0, then what is that? Tan phi is nothing but a minus u0 by omega 0 into x0. Okay. Now, what is phi? Tan inverse minus u0 by omega 0 x0. So, I know the phi value, I know the a value. I can write ax is nothing but a cos omega t plus phi. Okay. So, omega 0 t plus phi. So, omega 0 is the natural angular frequency of that motion. Understand? Now, same things, then what should be the u? Okay, this is the x, then what is u? I will use this thing in later on also. So, if I want to find out the u, it is nothing but a dx by dt is nothing but a u. So, speed is, so I can say minus a omega 0 cos, not cos, sin omega 0 t plus phi. Derivative. I can find out a acceleration d2x by dt square. That way I can find out acceleration also. So, I can find out acceleration. See that this is cos function, this is sin function. So, they are different, they are not in same phase. Okay. So, that I will discuss later on. Okay. Now, same solution, this is called sinusoidal solution. Similar things can be find out from an exponential solution. Okay. So, instead of write x is equal to a cos theta plus b sin theta, I can write same solution from that different to second order differential equation. X may be a1 e to the power j omega 0 t plus a2 e to the power minus j omega 0 t, complete solution in exponential form. Instead of cos or sin, I can write in e to the power. Okay. Now, a1, a2 is the arbitrary constant. Now, same, if I apply the same initial condition at t equal to 0, x is nothing but a x0 and u is nothing but a u0. So, at t equal to 0, if I put here, so x0 is nothing but a1 plus, okay, at t equal to 0 I put in here. Now, if I say the first order derivative, u is nothing but a dx dt. So, it is nothing but a1 j omega 0 e to the power j omega 0 t minus a2 j omega 0 e to the power minus j omega 0 t. I take the differentiation. Now, I put t equal to 0. So, u 0 is nothing but a1 j omega 0 minus a2 j omega 0. Okay or not? Okay. Now, if I say a1 minus a2 is nothing but a u0 by j omega 0. J omega 0 is common. So, u0 by j omega 0. Now, if I put the j in upper side, so it will be minus j u0 divided by omega 0 multiply by j lower side, j square is minus 1. So, minus j u0 by omega 0. So, this is equation number 2 and this is equation number 1. Now, using in 1, 2, I can find out the value of a1 and a2. Okay. So, what is the value of a1? a1 will be half of x0 minus j u0 by omega 0. Just substitution. Okay. And a2 will be half of x0 plus j u0 by omega 0. So, a1, a2 value I got. I got the value of a1, a2. If I put the value of a1, a2, I should get the solution. I should get the solution. Now, interestingly, if you see a1 and a2 both are complex. Both are in complex form. a1 and a2 both are in complex form. Okay. So, now let us consider that a1 is nothing but a complex form a plus jb. Let us consider a1 is nothing but a1 plus jb1 and a2 is nothing but a2 plus jb2. I can write down that a and b are complex number. So, any complex number can be represented by a plus jb. Okay. Now, I represent that way. Now, if I do that, a1 is like that and x is equal to a1 e to the power j omega 0 t plus a2 e to the power minus j omega 0 t. Now, if I put the value of a1 and here and a2 in here, so a1 is a1 plus jb1 into e to the power j omega 0 t plus a2 plus jb2 into e to the power minus j omega 0 t. Now, if I find out what is the real part of this x, I want to find out the real part of x. How do you get it? E to the power j theta cos theta plus j sin theta e to the power minus j theta cos theta minus j sin theta. If I put that things and then multiply, I will get a1 plus a2 into cos omega 0 t minus b1 minus b2 into sin omega 0 t. If I expand that things and find out the real part of that things, then you get this data. Now, real part of x. What is the real part of x? a1 plus a2. So, if I put the value of a1 plus a2, okay. So, what is a1? A1 is nothing but a x0 minus j omega 0 u0 by omega 0. Okay. So, this is A1 is nothing but a x0 or half is there. Okay. A1 is nothing but a, I write A1 is A1 plus jb1, small a1. So, small a1 is nothing but a x0. What is small a2? A2 is half of x0 plus j u0 by omega 0. So, a2 is also, small a2 is also x0. Okay. So, not x0, half of x0, here also half of x0, a1 plus a2, half of x0 plus half of x0 is nothing but a x0. So, it is nothing but a x0 cos omega 0 t plus minus is there. What is b1? Minus j u0 by omega 0 half. What is b2? Is minus half of u0 by omega 0 j. So, if I add them, it is nothing but a minus j u0 by omega 0, minus j u0 by omega 0. If I put the value in here, minus minus plus. Okay. So, I get here also I get x0 by, I will get x0 by omega 0 sin omega 0 t, u0 by omega 0 sin omega 0 t. So, this solution is same as we have derived in the initial. So, I can say real part of x, give me the complete solution of that same differential equation. Okay. So, real part also give me the, if the real part give me the solution, the complete solution is obtained if x is written in the form of, it can be easily proved that complete solution can be obtained if x is written in the form of x is equal to a e to the power j omega 0 t. So, if I write x is equal to a e to the power j omega 0 t is also a complete solution, where a is a complex number, a is a complex number. So, what is the complete, why I write this equation? Because in later on when we go for the design and acoustic wave propagation, we always say the displacement is in the form of a e to the power j omega 0 t. That is why I want to derive this equation. So, if this is the complex solution and then a is nothing but a complex number, so I can write a plus small jb, j small b. So, any complex number can be written as an r theta component. So, r and e to the power j theta, r is the amplitude and j theta is the direction. So, I can, so where r is equal to nothing but a root over of a square plus b square and theta is nothing but a tan inverse b by a, I can write. So, instead of a, I can write amplitude multiply by the phase. So, I can write small amplitude e to the power j phi, let us phi is the angle, e to the power j omega 0 t. So, it is nothing but a mod of a e to the power j omega 0 t plus phi. So, what is the real part? E to the power j theta cos theta plus j sin theta. So, it is nothing but a amplitude into cos omega 0 t plus phi for the real x. Same expression as we derived for the cosine transform, cosine part. Okay. Similarly, I can find out if x is in this form, I can find out u dx dt, I can find out acceleration dx square dt square. Okay. So, both way I can find out. Now, what is the energy of this? This is the equation of motion and equation of velocity, I understand. Now, what is energy exists in this equation, in this oscillation? What is the, how much energy exists in this oscillation? So, now if this is the oscillation, I know any simple harmonic motion in spring mass motion, there is a two kinds of energy. One is called EP, another is called EK. What is EP? EP is nothing but a potential energy and EK is nothing but a kinetic energy. So, any simple harmonic motion at any point has a two kinds of energy, potential energy and kinetic energy. Okay. So, first think about what is potential energy. What is the potential energy of these things? The potential energy EP is nothing but a integration of 0 to x. X is the displacement. Let us rest position, it is 0 and it is displaced to x. Okay. So, if it is displaced to x, so due to the displacement to x, the energy is stored. So, what is the energy? Integration displacement from 0 to x, the energy is stored spring constant into x into dx. If I have a spring, if I displace nothing displaced, no potential energy. If it is try to displace, that means due to the displacement of spring, I stored the mechanical energy or deformation. Displacement create deformation. So, I stored the potential energy. So, that potential energy, how to find out? Integration from 0 to x dx. Okay. So, if it is that, if I do the integration, what is the integration? Half of s x square. Okay. Now, what I said? X is nothing but a real part of x is nothing but a mod of a amplitude into cos omega 0 t plus phi. So, that is the amplitude cos omega 0 t plus phi. So, if I put that things, half of a square mod of a square into cos square omega 0 t plus phi, s will be there, s into a square, half of s into a square cos square omega 0 t plus phi, that is the potential energy. Okay. Now, what is the kinetic energy? Let us, kinetic energy EK is nothing but a half m into u square, half m into u square. So, if it is x, what is u? U is nothing but a omega 0 minus sin omega 0 t plus phi. Okay. So, let us a omega 0 t sin omega 0 t plus phi. Let us this portion has u, capital U. So, I can write minus capital U sin omega 0 t plus phi. So, it is nothing but a half m into square u square sin square omega 0 t plus phi. Okay. Now, if I convert, what are the conversion? What is u? U is nothing but a omega 0 into a. Okay, capital U. Now, what is omega 0? Omega 0 is nothing but a root over of s by m. S by m. Then what is s? I can write s is nothing but a omega 0 square into m. So, I put that value in here. So, half s means omega 0 square into m into, let us I write s square cos square omega 0 t plus phi. Okay. Okay. So, I can write let us that u omega 0 a. So, u square omega 0 square a square. So, omega 0 square a square I can write half m u square cos square omega 0 t plus phi. Okay. Now, what is total energy? Total energy, if it is E is the total energy, it is nothing but a potential energy plus kinetic energy. So, what is potential energy? Half m u square cos square omega 0 t plus phi plus half by the kinetic energy m u square sin square omega 0 t plus phi. Now, if I take the common half m u square, capital U square, then it is cos square theta plus sin square theta is equal to 1. So, it is nothing but a half m into capital U square. It can be proved that any point of at the maximum potential energy, that is E p max, is equal to the E k max. You prove it. It can be proved from that equation. So, I can say any point of time the energy stored in the resolution system is nothing but a potential energy plus kinetic energy, which is in the form of half, total energy is half m into capital U square. U is nothing but a 0 in a into omega 0. Okay. But EP max, maximum when the potential energy maximum, at that time the kinetic energy will be 0, and when the kinetic energy is maximum, the potential energy at that time will be 0. So, EP max is equal to EK max is equal to total. You can prove it, prove that, or we will discuss in tutorial how it is proved. Okay.